Hey everyone, and welcome back to another Prep to Perfection Grade 12 Math class. Just a quick reminder, if you boost your marks, you stand a chance to win 5,000 Rand. How amazing. Simply click the link down below to enter the competition. I'll now hand you over to your tutor, Camilla.
In today's video, we'll be taking a look at series. A series is a sum of terms of a sequence. So the difference, a sequence is an ordered list of numbers, a series is a sum of these numbers. We get different types of series. Finite series ends after a specific term, 100 would be our last term. Infinite continues indefinitely. Today we'll look at arithmetic series, geometric series, and sigma notation. An arithmetic series is a sum of a sequence of the numbers where the difference between each term is constant. The series we are given has a constant difference of 2. The general formula for a finite arithmetic series is the sum of the nth term is equal to n over 2 open brackets a plus the last term close brackets. Find the sum of the arithmetic series 2, 4, 6, 8, 20. Identify key values. The first term is 2, last term is 20. The number of terms we are unsure about. To determine the term number of 20, we use the arithmetic sequence and we determine the difference, and then we plug all the values we are given into the formula to get an answer that 20 is equal to 10, so n is 10. Then to work out the sum of the 10th term, we use the sum formula, plug those values in, and the sum of 10 is equal to 110. Geometric series, each term is multiplied by a constant ratio. So 3 plus 6 plus 12 plus 24. The general formula for a finite geometric series is the sum of the nth term is equal to a open brackets 1 minus r to the power of n over 1 minus r, where r cannot equal 1. Then the general formula for an infinite geometric series is the sum is equal to a over 1 minus r. The first sum of a geometric series is 4 and the common ratio is 3. Find the sum of the sixth term. We are given a, which is 4, r, which is 3, and n, which is 6. From here, we use the sum formula, plug in our given values, and get that the sum for the sixth term is equal to 1,456. Sigma notation, n is equal to 4, it's the upper limit where it stops, I equals 1 is the lower limit where it starts, I is the argument, the expression to be added. In this case, we start with 1 and we end at 4, so 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 1 equals 4, and then the sum of it is 10. Expand the sequence and find the value of the series. The general formula for the number of terms is the upper limit minus the lower limit plus 1. The upper limit is 6, the lower limit is 2, and then we plus 1. So 6 minus 2 is 4, 4 plus 1 is 5. We use the argument we're given 2n plus 1 to work out the first value we start with. We plug in n equals 2 first to give us 2 times 2 plus 1. For each next term, we plus 1 to n. So if we started with n equals 2, then the next term will be n equals 3. So then we'll plug 2 times 3 plus 1. The next term will be 2 times 4 plus 1. 2 times 5 plus 1, and then 2 times 6. And this will give us our sequence of 5, 7, 9, 11, and then 13. Convergent and divergent. Convergent series approaches a finite value. Divergent series sum grows indefinitely. Convergent, as you can see, it approaches 0, so it's less than 1. Check if the series is convergent or divergent. We use the p-series test, which is a general form. P is a constant. Given our series, we can see that p would be 3. This is greater than 1, and we can state that the series is divergent. When a series is convergent, r is greater than -1 or less than 1. Infinite series are convergent. This is where we get sum to infinity. A metric series has a first term of 5 and a common ratio of 0.8. A is equal to 5 and R is equal to 0.8. Determine whether the series has a sum to infinity. If it does, find the sum to infinity. For it to have a sum to infinity, it must be convergent, so 0.8 is less than 1 and it converges. To work out the sum to infinity, we use the sum to infinity formula, a over 1 minus r. We plug our values in that we know, and our sum to infinity is equal to 25.
Alright everyone, that's it for today. But don't forget to keep practicing so that you stand a chance to win 5,000 Rand. Click the link down below to enter the competition and we'll see you in the next class.